Good morning, good afternoon, good evening, wherever you are, wherever you're watching this video. I hope you guys are doing well. In this video, we are going to talk through how to find the volume of a cylinder. And so we want to go back to what we've learned already, okay? We want to build upon what we've already learned. So we've talked through the volume or the surface areas of these structures. Now we're moving to volume, and the same characteristic follows. When we talked about surface area of a prism, we said that that formula followed the same formula for the surface area of a cylinder. And so the same is true with volume. Volume of a cylinder, that formula right there, is going to be the same exact thing as the volume of a prism. And so if we think about it, the volume of a prism was base area times height. Base area times height. Okay? Now, the base area within this structure right here is going to be the circle right there. Well, what's the formula for the area of a circle? It's pi radius squared. And the height doesn't change, so that's all it is. Pi r squared h gives you the volume of any cylinder, okay? And so when you look down here at the first problem, okay, it does say leave in terms of pi, and so volume equals pi radius squared height. If I just plug in the information that I'm given, here's my radius, here's my height, I should be able to go ahead and figure out this answer in terms of pi. If I square 3, I get 9 times 8, which is 72. The answer of this volume of this cylinder is going to be 72 pi cubic centimeters, okay? Cubic centimeters there. So not very hard. I told you that cylinders and cones are really simple after we've learned pyramids and prisms, and so that's what I want to make sure you understand, okay? Not very hard. Now, if we take a look at the next one, this shape looks a little bit different than all the other cylinders that we've covered so far, and there's actually a name for this type of shape. But in order to know the name of this shape, I want to go back to the name of this shape. This shape we would call a right cylinder. Okay? Now, you could have a right cylinder, you could have a right pyramid, a right prism, or a right cone. And what that means is this, that the bases are directly over the top of each other. Okay, the bases are directly over the top of each other. Now, something I want to make sure that you understand about that is this. Why do they call it a right cylinder? Why right? Well, I think what it really comes down to is this. The height and the base of these structures, when the bases are directly over the top of each other, is a right angle. And I think that's why they call it a right cylinder, or a right pyramid, or a right prism, okay? For this one, you notice that the bases are offset. They're not directly over the top of each other. We call these structures oblique. Oblique, in this case, cylinder. Okay? And what's an oblique cylinder? You could probably guess it from your definition of a right cylinder. It's just that the bases are not directly over the top of each other. Okay? And so there's something about, you know, I'm sure there's something embedded in the word oblique that tells us why they call it that, but I haven't researched it, so I apologize about that. Maybe you guys could Google that. What does the word oblique mean, and maybe why do we call it the oblique cylinder like that? But anyways, here's what I want you to know. The distance between the two bases, the shortest distance between the two bases is what we call the height, okay? We've known that for a while. In this problem over here, the shortest distance between the two bases, now let's think about this, is this distance right here shorter than this distance right here? And the answer is no. We know that the shortest distance between a line and a point, or two different objects, is a perpendicular line to both objects. And so as a result, that's what we want to do right there. That is going to be our height, remains our height, which is why it's given to us. Okay? So if we set this up, volume equals pi radius squared height. The radius is half the diameter. The diameter in this case is 8, so we have 4. The height is 16. We end up with 16 times 16. 16 squared is 256. And so the answer in terms of pi of the volume of this cylinder is going to be 256. Ooh, about made that mistake. Watch that there, folks. 256 pi meters cubed. Okay? Meters cubed. All right, now let's turn over the back side where we've got a backpack structure that we want to find the volume of. And this is like the composite figures that we were working on the other day. And so we actually have to kind of rework our thinking on how we use the formulas here. So the first thing I'd want you to do, or I challenge you to think of, is what two structures make up this backpack right here. And as you look, I hope you could see that this structure down here, okay, is going to be a prism. So the volume is going to be the volume of the prism plus, and this structure up here is actually a half cylinder. Okay. Now before we actually plug in some values here to this, here's what I want you to know. Again, surface area is more difficult than volume because volume is what's internal. And so surface area isn't what's internal, it's what's external. So we actually had to kind of modify our formulas when we did these problems. Now we don't have to because we're calculating everything on the inside, whether it's separate, the two objects, the prism is separate from the half cylinder, or together. And so that's the good news. So as you think about this, volume of a prism is base area times height. If I look at this, the base area would be this structure down here. Okay? And so when I go ahead and figure out the area of that base, it's 12 by 4 times the height of the prism. Well, how far is this point to this point right here? Because that would give me the second base of that prism. All right, so how far is this? What is this length? Well, how do we figure that out? That's the hardest question, to be honest with you, in this whole problem. And how we figure that out is this. If you think about it, you know this length already. That's 12 inches. Well, if I go ahead and take this figure from here, the center, over to here and rotate that right there, this length right here is going to be half of the diameter, 6 inches. How does that help me out? Well, if that length is 6 inches and the whole length is 17 inches, I can take 17 minus 6, I get 11 inches, and that's the height of my prism. Okay? So the base again is a 12 by 4 base with a height of 11 inches. Okay? Now, I'm actually going to go ahead and get rid of some of this over here, actually all of it, so we can see it a little bit better. Clear that up, what we just said. This length again is 11 inches. Okay, and this length right here is 6 inches. Okay, so from there we're going to add in a half cylinder. All right, well, the cylinder formula, as we discussed on the previous slide, is pi radius squared. When we figured that out, that was 6 inches squared times the height of the cylinder. Now, it's important you recognize that the base, there's one part there, and there's one part here. What's the distance between those two bases? Well, that length will be this distance right here, okay, which is 4 inches there. Okay, so again, this is pi radius squared times height. And then you just have to simplify it up. Now, if I go ahead and multiply 12 times 4, that's 48, times 11, I get 528. Okay. Over here, we can take 36 times 4, 120 and 24. right? Yeah, so 144 divided by 2, that's 72. Half of 144 is 72. So this is 72 pi. This would be your answer in terms of pi. Remember, we can't add, oh, almost made that mistake again. We can't add pi to this over here. We treat that like a variable, okay? If you were to go one step further, because I really didn't put any directions on this one, you could finish it off by go ahead and plugging it all into your calculator. And this would be an approximation, nearest tenths place, of the volume of that backpack. 754 cubic inches. Okay. All right, now I have an interesting problem down here that I actually have kind of an embarrassing story on. One of my first years teaching, I thought that this was a great, problem to give. So I scanned it in, projected it up, and we're talking about it in class. And I'm starting to look at it, I'm like, oh man, this is not good. Not good at all. And we would come to realize that there was a problem within this problem. And that's this. The directions say this. I would ask you to determine the volume of this composite figure, but the diagram has an error in it. Therefore, describe the error, what the error is, and how it can be corrected. Okay? So right now, it would be a great time to just pause your computer. Look at the figure, look at the structure, look at the dimensions, and I'm going to tell you right now, there's some dimensions that do not agree with each other. So do that, take a minute, see if you can figure it out. If you can't, press play on your computer and we'll talk about it. Okay? So, where is the error? Now you can actually come at this error from two different directions, and we can talk about both directions here. But one way it would be is if this is 11 inches and this is 15 inches, then the difference from 11 to 15 is going to be 4 inches. So the radius of my circle out there is going to be 4 inches. Now if my radius is 4 inches, my diameter would have to be 8 inches. Well, if that length is 8 inches, then this length is 8 inches, but that length doesn't agree with that length. And so this guy would have to go, and he'd have to become 8 inches. Okay? That would be one way to fix the problem. Now to come at it from the other direction, let's start with the 12 here. If this is 12, then this is 12, then this is 12, and what's the radius length? Well, it would be 6. And if that's 6 inches, and this is 15 inches, the whole thing, that means that this length would have to be 9 inches right there. So I'm going to get rid of that guy, and now I can actually go ahead and solve the problem. So again, if you were able to do that on your own, kudos to you. You're starting to know your way around figures and be able to look at the dimensions and how they work together, which is awesome. If not, no worries. I like that problem. What I'd like you to do, go over to the website, take a look at the homework for tonight, and see if you can start to do that. Again, you need to have the homework complete. You need to be able to do it to 100%. Every problem has to be right. Okay? So have a good night, folks, and I will see you later.